So this video is to get you comfortable with the mole, to think in moles, to be able to handle AP style multiple choice in moles without the presence of a calculator. I will be doing a lot of rounding here and ignoring sig figs, which is what you probably should do when you're doing multiple choice, unless sig figs is the goal and the question. So let's start off with oxygen here. Let's imagine we have 1 mole of oxygen. What else do we know about that? Well, we can look up oxygen and we find from, and this was in the previous video, right? We found that the gram formula mass for oxygen was 32 grams. So we can put that right here, 32. And that's going to be, I'm not going to write grams because that's gram formula mass, or molar mass. It's the mass of 1 mole. We should be able to answer all the other questions here. If I have 1 mole of oxygen, okay, right? Since 1 mole weighs 32 grams, the mass of that 1 mole will be 32 grams. This number of molecules. Well, Avogadro's number. If you have 1 mole of a substance, you have 6 times 10 to the 23rd molecules. Now, for oxygen, the number of atoms and the number of molecules are not the same because oxygen is a diatomic molecule. So every single molecule of oxygen contains 2 atoms. So if you have 6 molecules, you would have 12 atoms. If you have 6 times 10 to the 23rd molecules, you would have 12 times 10 to the 23rd atoms. The volume at STP. For gases, this is always 22.4 liters. That's for an idealized gas. We'll find later that gases do deviate from the ideal. And we'll talk about how they deviate, when they deviate, in terms of conditions, and how we can quantify that. But that comes later. Finally, the density. Well, the good thing about this is for a gas, you can always take the mass of the gas and the volume of the gas at STP and figure out the density. Now make sure we're clear, this density is at STP. The density of a gas will vary under different conditions. So if we take 32 and divide it by 22.4, we get 1.4 grams per liter. Now what if we had a different quantity of oxygen? Let's say instead of having 1 mole of oxygen, let's say we had a volume of 11.2 liters of oxygen. Now the gram formula mass is not going to change and we're still dealing with oxygen. However, we don't have a whole mole now. 22.4 liters would be the volume of 1 mole of a gas at STP. If we have 11.2 liters of a gas at STP, then we don't have a full mole. We have a fraction of a mole. We have half a mole, 0.5. And from that information, we can discern what would be in all the other columns. Let's start off with the easy one, density. If we have half a mole, the mass would not be 32 grams, it would now be 16 grams, because 1 mole weighs 32 grams, half mole weighs 16. If we take this number here and put it over this number, well, it's a proportional relationship, isn't it? And density is an intensive physical property, meaning the density of a substance is not going to change based upon what quantity you have. However, if you change temperature or pressure, and there's a whole chapter on that, we'll get to that, the density will be the same. The number of molecules here will not be the same, though. We have a half a mole. Instead of having 6 times 10 to the 23rd molecules, by the way, way rounded. We're not going to do this when we do free response. We would have 3 times 10 to the 23rd molecules. And the number of atoms, well, there's 2 atoms per molecule. If we had 3 molecules, we'd have 6 atoms. If we had 3 times 10 to the 23rd molecules, we'd have 6 times 10 to the 23rd atoms. So, what if we're dealing with a different substance? And how could we figure out which one's which? So let's say we have a choice here. We have carbon dioxide, formula mass 44 grams per mole, and with helium, whose formula mass is 4 grams per mole. Now let's make sure that carbon dioxide is a molecule with 3 atoms, 1 carbon and 2 oxygens. It's a linear molecule, symmetric, you've seen this before. And helium is a monoatomic molecule. So let's say I have a next row here, and I don't tell you which of these 2 substances it is, or it could be any of the 3, let's say. Right, and I say to you, the mass I have 8 grams, and within those 8 grams, right, there are 12 times 10 to the 23rd molecules. Well, the key thing here is to think in terms of moles. If I have 12 times 10 to the 23rd molecules, your brain should immediately say, hey, that's 2 times 6. I have 2 moles. And so what this tells me is 2 moles weighs 8 grams. Since 2 moles weighs 8 grams, that means 1 mole must weigh 4 grams. which means I can now identify this as helium. And I can fill in the rest of the chart as well. For atoms, in this particular case, since it's monoatomic, every molecule is just made of a single atom. So the number of molecules and atoms in this case will be exactly the same. The volume, well, it's 2 moles. So if 1 mole has a volume of 22.4 liters, and it doesn't matter what gas we're talking about, that's the weird thing. And it is kind of strange. But this is what they found out. That's why there's an ideal gas law that covers all gases, because if you have 2 moles of a gas at STP, ideally it will take up 44.8 liters. Now the density is not going to be the same because this is a different gas. So we have a choice. We can put 4 over 22.4, or we can put 8 over 44.8, but we get the same answer. We get 0.18 grams per liter. Now that's a lot less dense than oxygen. This explains why helium balloons float, and it also explains why your voice gets high-pitched when you inhale helium. By the way, fun fact, if you inhale a denser gas like argon, your voice actually gets deeper. You can find it on YouTube if you're really that interested in it. All right, I'm going to now give you 2 more rows to fill in. So you should pause it after I put the information into the row. So in each of these rows, you have enough information to determine which substance the row is referring to, because there's enough information to determine what the formula mass of the substance is. So I suggest you pause and try to figure it out. I'm going to pop the answers up, so I would pause now. All right, so those are the answers, and I'm just going to quickly go through what I did. I knew I had 1/4 of a mole here, and I knew that 1/4 of a mole weighed 12 grams. So if 1/4 mole weighs 12 grams, that means a whole mole must weigh 44 grams, and because of that, I figured out it's CO2. Okay, so the sample I had was 1/4 of a mole, and instead a whole mole is 6 times 10 to the 23rd molecules, so 1/4 of a mole would be 1.5 times 10 to the 23rd molecules. But each CO2 molecule has 3 atoms in it. So I took the 1.5 and multiplied it by 3 to get the 4.5, so I have 4.5 times 10 to the 23rd atoms. In terms of the density thing, well, just basically take your mass and put it over your volume, or you could just put 44 over 22.4, and that would give you the density. For the next row, I knew I had 3 moles, and that was 67.2 liters. So I knew I had 67.2 liters. I knew that's 3 moles because 22.4 goes into that 3 times. So I had 3 moles, and the 3 moles had a mass of 12 grams. If 3 moles weighs 12 grams, then 1 mole weighs 4 grams. That's helium. And since I have 3 moles, that's 18 times 10 to the 23rd, 3 times 6, monoatomic, so it's 18 again. And the density, coincidentally, is 0.18. That I just use the same thing because it's an intensive physical property. Now, the problem with it is this. I'm going to give you 1 more row to do, and maybe you want to try to figure this out. If you can handle the next row, then you might not watch the next video. Because what I'm going to do is I'm going to tell you that this is oxygen. And I'm going to tell you that the mass that I'm giving you is 2.73 grams. And you should be able to figure out all the other items. Now, if you can't do that because it's not a nice even number, that's okay. That's why there's a 3rd video. Because the reality is sometimes you're going to have to do math. So I'm going to pause this one. I'm going to put the answers up, but I'm not going to explain the answers. That will happen in the next video. So here are the answers. I will give you 1 hint. The central unit is this. If you figure out the number of moles, which is easy to do because you have oxygen, and you had this 2.73. If you divide that by 32, that gives you this number right here, 0.0853. And basically you're taking the given mass and dividing it by the gram formula mass. Once you have the number of moles, you can figure out all the other stuff based upon that. This is the central unit, and when I go over this in the 3rd video, I'm going to focus on getting everything into moles first, and then I can answer all the other questions. This will be a critical skill for a lot of stuff we do this year.